Hello everyone. Now we're going to talk about the template design pattern. In front of us we have the definition of the pattern, the definition of the intent of the pattern, and as this is taken again from the Gang of 4 book, and we can see that as usual this kind of definition is much more useful for people who already know what this template is all about than to teach anyone what's the logic behind this template, because it's definitely not very clear what we're talking about here. Define the skeleton of an algorithm in an operation, deferring some steps to subclasses. Template method lets subclasses redefine certain steps of an algorithm without changing the algorithm structure. Well, as usual, it's correct, but not very clear. Of course, it's useful to have a standard definition like this, just to check that your understanding respects the standard, let's say. But to explain to you what this pattern is all about, I think we have to do something else. As usual, it's best to explain with an example. So here we have already a little bit of code. We have an order class, as you can see, which has some simple properties. It has an ID, it has a cost, it has a payment method and a shipping method, which are members of the enumeration payment method and shipping method that you can see here. So the payment method can be credit card or bank account, and the shipping method will be flash, decent, kind of slow. And going back to the properties of the order, just to familiarize ourselves with this class, we can see that we also have a shipping cost, which is of course the money that you have to pay to get your stuff sent to you, and the total cost, that's just the order cost plus the shipping cost. Okay, so what do we do with these orders? Well, let's say that of course we want to sell stuff, so we need an order processor, which will have a method process, which is the main algorithm of our software. It's the most important because of course it's necessary to sell our stuff. And while we are designing this algorithm, we are thinking about this algorithm, we start to realize that, for example, well, the processing of our order will have to calculate the total, and that will not change in any circumstance that we can foresee. And then we'll have to do some kind of processing of the payment. Since we are already kind of experienced developer, we think about it and we can foresee that we're gonna have some change here, because we will have, for example, let's say that we will have domestic orders and foreign orders, and we want to distinguish them by payment. So the payment won't be the same for domestic or foreign orders. So this is kind of a change point. This is going to be something that we'll have to worry about. Then we'll have to update our stock, and that will always be done in the same way. And we will have to choose a shipping method and apply shipping cost. And this also we can foresee that it's going to change for domestic and foreign orders. So this is going to be another extension point that we'll need to worry about. And finally, the notification to the customer will be the same for everyone. So here is our problem. Let's say that we have no problem in performing all the steps that we have isolated in our algorithm. For simplicity, I would just say that when we calculate the total, we just say console write line, calculating total, and so for the other operation. Because of course I don't want to distract you with complicated code just to pretend that we are doing something real and not an example to teach you something. I prefer to do very, very simple examples so that you can concentrate on the main idea and you don't get lost in all the details. So even with this simple implementation, if we can call it so, we have a problem, because yes, calculating the total will be the same for everyone, but processing payment is not going to be the same for everyone. And the same goes for choose shipping method and apply shipping cost. So we are not going to be able to have a single and simple process method inside our order processor, because a single method is not going to cut it with all the variation that we'll need to make. So what do we do? Well, the most primitive and not very wise solution will be to say, okay, I know a little bit of object-oriented programming. I know what to do when I'm not able to give a concrete implementation to some method. I mark that method as abstract, and I will make subclasses that redefine that method. So the most brutal way of solving this problem will be to say this: okay, let's forget about the concrete implementation of the process method in the order processor, and just make this method abstract. We'll do like this. We'll just comment out all the content of the process method. So we'll turn the process method into an abstract method, and then this order processor class will also need to be abstract. And what will we do? We will go on and create some subclasses of the order processor. Here I already have the skeleton of the class, and then we'll go on and give an implementation of the process method for the domestic order processor, and of course the same will go for the foreign order processor. So we could go on and implement a completely new process method for the foreign order processor and another process method in the domestic order processor. But that's not the ideal solution. Why? Because in the process method, if you go back to its steps, we'll find that a lot of stuff will be the same, both for the variation of the domestic order processor and for the variation of the foreign order processor. We'll end up with two methods that are like 80% the same and just differ for a few details. This is not a situation that we want to be with. We don't want to have duplicated logic. So for the sake of clarity, let's see with an example what I actually mean with the fact that if we just use the stock idea of the abstract method in the parent class and concrete method in the child classes, we'll end up with a lot of duplicated code. So let's actually copy this part and go, for example, in the domestic order, get rid of the comments, and then if we want to give the implementation here, we'll say, okay, calculating total. That this doesn't have anything to do with the fact that the order is a domestic order. And processing payment, we could just write processing domestic payment, but actually let's write a little bit of code here, and let's say that process order payment method, let's say that we don't, for some reason, we don't trust orders with the credit card which are made for abroad, but for orders that are domestic, we don't have any problem with that. So payment method, it's gonna be CC credit card. Then we update our stock, and we have to do something to choose shipping method and apply shipping cost. So let's get rid of this. And let's say that we want to say that the order shipping method will be something fast, because we're going to do a domestic order. So it's gonna be shipping method dot flash, and also the cost will be order shipping cost will be something like the standard ship cost that we already have defined up there. So it will be our standard cost. Fine, that's the implementation for the domestic order processor. You already can imagine that this is going to be very similar to what happens in, for example, in the foreign order processor, because the steps are going to be the same. Only here, for example, order payment method will be bank account, let's say, for the for this guy here, and the here we also need using system, which I don't see. So here, all that will be different is just the fact that we're gonna change this step, and we're going to also change this step when we don't want to have a flash foreign shipping method, but we'll do something like kind of slow. And shipping cost is going to be standard ship cost, but of this class, which is the foreign order processor. And the notification to the customer will be the same as before. So this actually could work, but it's not very good because we have a lot of duplicated logic in this process method, in this process method. And it's a little thing here, but you can imagine that in a real situation you're going to have much more code that gets duplicated, and also code that has a lot of logic in it. It's not just assigning values to properties. So what do you think? What could we do to improve this situation? Well, when we are in difficulty, my advice is always go back to the fundamental principle of object-oriented design and see if they can help. One of the most important principles is isolate what varies. Isolate what varies. So if we follow this advice, we could say, you know what, if we go back to the definition of the algorithm, all these steps, calculate total, process payment, update stock, blah blah blah, maybe they could deserve their own method, and let's see if this can help us in any way. Doesn't look like it's gonna help us in at first look, but sometimes you can get insight only after you have modified, only after you have improved the original situation a little bit. So we are not actually creating a method for each one of these steps, because for example, calculate total is not going to change. We only want to isolate what changes. So we definitely need something to process the payment. So public void process payment. And this is going to change, so what do we do? Well, here it's good to follow the general standard practice of making the method abstract. So public abstract void process payment. We don't know at this moment what we can do with this method, so let's just leave it abstract. And then update stock will be the same for everyone. And then choose shipping method and apply shipping cost instead are two different steps that we have to consider and will change. So let's do it like this. Public, we already know that we're going to have this as abstract. Void, choose shipping method. And of course, all these methods will have to take the order that they're going to work on. The shipping cost, no problem. And that's it, because notify customer will be the same for everyone. So we have these three methods that are problematic. So what do we do after we have defined this method? Well, we want this method to be called by the original method, right? But here the original method is abstract, so it doesn't have any implementation. It's kind of confusing. But let's go, for example, here in the domestic order processor. Since we have defined those three abstract methods, you see now that domestic order processor doesn't compile because the compiler really badly wants us to define what these three steps are. So let's actually move the code that has changed inside these three methods. So for example, for the apply shipping cost, we'll go here and take this code. So for the apply shipping cost, we'll go here, take this code, cut it, and use this to complete this method. Voila. Then we'll do the same for choose shipping method. And just before we do this, here what do? We call the method that we just create, apply shipping cost. Then we can do the same for the payment method. Let's start from the top this time. And let's actually move this guy here with these brothers here, because otherwise It's messy. So process payment will be like this. And here, of course, we're going to call process payment of our order. And then, final step is shipping method. Let's cut the implementation. Let's cut this complicated, very difficult implementation and pass it here. And then choose shipping method. We'll go here. Okay, and so now we have a kind of better implementation in a way of the process method, but the idea is that like this, if you go on the foreign order processor, a lot of things will be the same again, which is not a very good idea, which is not a very good sign. So basically we'll be in the same situation here. Okay, right, let's do it again. Calculating total is the same. Payment method will go here. So bank account will be our choice for process payment for foreign orders. And here, process payment, let's go, of our order. And then we update the stock, and then the shipping method, you go here, choose shipping method, great. And then finally the shipping cost. Okay, now our code is a little bit more structured, but we haven't made such a huge step forward because, yes, we have these little cute methods that isolate what varies, but the original problem is still here. The process method is still duplicated in every subclass of the order processor. If we look at it, actually, now it's not just that a lot of its logic is duplicated. If we look at this, the process method here, console write line, calculate total, process payment, console write line, update stock, choose shipping method, apply shipping cost, console write line, notify customer. Is there anything here that's particular only to the foreign order processor? No. If you go to the domestic order processor, we find out that the method is exactly the same. It is exactly the same. So apparently we have made things worse because first we had like 80%, 70% duplication. Now we have that 100% duplication. So it looks like we made things worse, but we didn't. Why? Well, because if it is 100% the same, it means that we can take all this code here, go in our original class, and paste it here. And this method doesn't need to be an abstract method anymore. So we're gonna make a little bit of open heart surgery to this poor method, but then again, here we are. So this method can actually sit here. It doesn't need to be an abstract method anymore, our primary algorithm, our primary method process. But wait a second, is this alright? Because actually this concrete method, this normal concrete method is calling some abstract method, like for example process payment. Is this possible? How can it be that a concrete method, which is supposed to know what it's doing, is actually calling an abstract method we don't have any implementation? How can it be? Well, actually it can be, and the template method design pattern is actually all in this little insight. It's just here, no? Realizing that you can have a concrete algorithm, you can have like an algorithm that's very complex and have a lot of steps, and it can be implemented as a concrete method, as a normal method, which calls a few abstract methods, which will be defined in subclasses. In this way, the subclasses will only have to implement what changes, what is different, those little steps, and not the whole method. So you don't have to reinvent the wheel all the time from zero, and you don't have to duplicate the wheel from zero every time, if I can say so. And there's no problem because, yes, this concrete method is called an abstract method, but you won't be able to call this method on an order processor anyways. Why? Because since it has abstract method, it is an abstract class. So you cannot create instances of order processor and call process on it. So this is safe, this is perfectly, and you see the compiler doesn't blink, doesn't have anything against it. So what happens now is that we can go, for example, to our foreign order processor and just completely get rid of this method. And look at this. Now the foreign order processor just have to give an implementation to what varies, to the little steps that varies, like apply shipping cost, choose shipping method, and process payment, nothing more. And of course the same goes for the domestic. The domestic here, you see, you just already got rid of the process method, so you just have the implementation of the varying step of the algorithms, the steps that are actually different for every scenario, and the class is done. And then if you want to make another kind of order processor, you're free to do so, and again, you only have to implement the variable part of the algorithm, not to write the whole algorithm once again. So I think you already got this by now, but just to make sure, let's make, for example, the scenario where you need another order processor, let's say one for internal customer. So we create another one. And then here, let's actually copy and paste because it's gonna be very much the same. So here it's gonna be internal customer. It's gonna extend order process. Gonna have, let's say that for internal customer we go for free, and then apply shipping cost. Let's say that. And so for choose shipping method, for internals, we are going to have something a little bit different. So decent. And for process payment, we'll go for credit card. And we're done. We just defined the steps that were varying step, that were different, and we already got the process method for free for the internal customer order processor, because it's the method that we inherited from our superclass. And here is the class diagram, just to see what we did from another perspective. We have our abstract class, which is our order processor, which defines the template method, which is the complex algorithm, our process order method. And then there are one or more, doesn't really matter, can be one, can be more, little steps that are left abstract in the abstract class, and then are given an implementation for every concrete class that I need to extend the original abstract class. And here in our, if you remember, we have here a second project, which is the few unit test, just to make sure that the code that we wrote is actually working. And here you can, as you can see, what do? I just define a couple of variables, saying that I expect the shipping cost for foreign orders is 100 and the domestic shipping cost is 550. And then I say, okay, let's say that I want to spend $2,000 on an order, and here is the domestic order processor, which ID1 costs $2,000, and I'm going to say, okay, I'm going to process this order, and what do I expect that the cost is? The original cost, because it doesn't get touched. And then the total cost, I expect it to be the original cost plus the domestic shipping cost, and the shipping method I expect it to be Flash, and the payment method I expect it to be CC. Why? Because that's how the little methods that I define in the domestic order child class behave. The shipping cost is the standard ship cost for domestic, shipping method is Flash, and payment method is CC. And of course the same goes for the other guy, because then I have another method which checks the processing of foreign orders. And it does pretty much the same, but it expects, for example, a shipping method of kind of slow, and a bank account paying method, and the foreign ship cost. So what do we do? So let's actually see if this works. Cross your fingers, guys. And it looks like they all work. And you can find all this code to play around with it in the GitHub solution that's associated with this series of tutorials. So guys, that's it. It wasn't too painful, right? Now we finally know what it means that the template method design pattern defines the skeleton of an algorithm, which defines the process order algorithm here in the main class with all this logic that you can see here. But then deferring some steps to subclasses. Which are the steps here? Well, the steps, as we saw, are process payment, choose shipping method, apply shipping cost, while all the algorithm, other parts of the algorithm already are expressed here and because they don't need to change. And then what happens is that these steps that are being deferred to subclasses, of course, will have to be defined by the subclasses. So for example, the domestic order processor here, this guy here, will have to define the missing steps: apply shipping cost, choose shipping method, and process payment. So that's it, guys. I think that template method now doesn't have any circuit for you anymore. As I told you, the main insight is to realize that I can have a concrete method which is calling abstract methods, and in this way I can override only this little abstract method in the subclasses, and this allows me to do a more refined way of redefining method. Just not redefine one big huge method which ends up being 80% the same in every class. Just be a little bit smarter and redefine only the little steps that actually change. And that was the template method patterns for you.